Yeah, just say live and then start the transition. Started. So good evening, everyone. Welcome to this session on Introduction to Mechanical Design by Electronics and Robotics Club. Good evening, everyone. Welcome to this session on Introduction to Mechanical Design by Electronics and Robotics Club. I'm Abhishek Dixit, and I'll be carrying you through this session. So let's look at a few examples, or rather, uh, projects that have been done by ERC. So on the left, you can see the modbot, and on the right, you can see the quadruped. You can see the various types of mechanisms here, and the design that has gone into making these bots. So this is just a gist of what mechanical engineering has its application in robotics. Let us find out in the following sessions. So what basically is mechanical design? Mechanical design involves designing of parts, components, products, and systems. And it also uses physics terms like inertia, force, load, material use, etc. So if you want to find out how much of load or how much of force is to be supplied on a bot arm, then you need mechanical design to calculate that required force or load. So we also need to identify the type of material that is supposed to be used in particular component of a robot, and that's where mechanical design or mechanical engineering helps us. You can think of mechanical design as analogous to the skeleton of a human body. So as skeleton gives a specific definite shape to a human body, that's how mechanical designs give a proper shape to or any robot or a machine for that matter. Relevance of mechanical design in robotics. So there are few listed here. I'll discuss one by them. If we want to determine the trajectories of a robot, which path it undertakes, and to perform a specific function, we need mechanical design for that. Um, and bot performance under specific constraints. So we might have some conditions wherein the bot is supposed to not perform this function or that function. So we need that. Design optimization. We cannot go around with bulky models for a bot. We need to optimize the design so it has to have more modularity and functionality. We need to try to simulate the bot in a particular environment under some constraints, so that we can actually see how this goes into making before actually building the robot. Mechatronics and CAD-CAM labs. So CAD-CAM labs are basically designing softwares in which you can design a particular robot. So let us try and right now we have seen what is mechanical engineering and where what is the relevance of it in robotics. So you might have a question right now. Where do we start from? So well, let's have a look. Simulation. As I said, before building any robot, we can try to simulate it in a particular environment under a few constraints and conditions. So how do we do that? There are a few programming softwares like MATLAB and Simulink, wherein you provide few equations of constraints and or a few equations for what path the bot is supposed to follow. And how do you get those equations? So there's these things called kinematics and dynamics. You might have heard them in your classes. So in by applying kinematics and dynamics, we can derive a set of equations for which the bot is supposed to follow a path. Well, if we can see the blue line over here, So this is the path that the bot is supposed to follow, and the red points determine the constraints over here. So these three red circles here define the constraints, and the blue lines determine the trajectory of the bot that is supposed to follow. So this is one aspect of mechanical engineering and robotics. We'll have a look at the next aspect, machine designing and robotics. So after before simulation, we need to actually have a design of how our bot is supposed to look like. So if you look on the image here, there are a few views of the bot, as when viewed from the top side, the bottom, the front, back, and many other views like that. So this aspect focuses on principles like mechatronics, and as I discussed before, CAD CAM and total quality management, etc. And we also need to take into account the theory of mechanics of solids. So mechanics of solids basically mean how much of force is supposed to be applied at a particular point to extract the effort, required effort. So that is there in the machine design in robotics. The next aspect is components of machine design in robotics. So we have several components which try to which when assembled together give us the final shape of the robot. So on the in the gifts in the slide, you can see that there's an universal joint and there are sensors. So this is how mechanical engineering is involved in robotics. We need to give a set of equations over here so that these can perform the specific functions like this. And over the sensors here, we already have the sensors. We need to just give them the constraints and the conditions, and we'll get the final result. So describing more about the components of mechanical engineering, we have actuators. So what are actuators? Actuators are basically the devices which help us to perform a specific function. So if you can see here, there are different types of actuators like hydraulic actuators, electric actuators, and many other stuffs like pneumatic actuators. So actuators basically help us in performing specific functions without having the need to go through the physical effort of doing it ourselves. So that is there. And moving on to the next component, we have motors. So motors basically help us in deciding the motion of a bot in a particular direction. So actuators and motors almost similar, but quite entirely different in the functionality, but their purpose is the same. So we have BLDC motors here, DC motors, AC motors, servo, stepper. You might have heard of AC and DC motors in your high school. So let me talk a bit on the servo motors here. So what is a servo motor? Servo motor, as I said, is basically like a rotatory actuator. If you can see the gears over here, we can see that the main function of the if of this servo motor is to provide a rotatory function, and it also allows us to control the angular and the linear position or the movement of a bot precisely, and we also get to control the velocity and the acceleration of these movements. So this is about the stepper motor. And one more point to discuss in the motors, so there are something called as stepper motors as well. I'm sorry, I don't have the gif for that here, but stepper motors are something like a DC motors which follow or do a particular function in discrete steps. So they have multiple coils in them which are organized in what we call as phases. So each movement takes in a particular phase and then goes on to the next. This is the advantage that stepper motors have over servo motors. So in stepper motors, you have greater precision, greater control over the moment, velocity, acceleration of the particular component of a robot. So that's there. And moving on to the next component, wheels. So every bot needs to have wheels in order to actually move the robot. So if we want to move the entire structure, we need wheels. So the first one is caster wheels. So the caster wheels aren't actually actuated, but they allow the movement in any direction. So you might have seen in supermarkets wherein the trolleys, the shopping cart trolleys have wheels like this. So these are nothing but caster wheels. The pin joint here has the perpendicular axis which can allow the board to move in any direction with the entire structure. On the right hand side you can see the another type of wheel called omni wheels. So omni wheels are the ones which are actuated in the sense that they can move laterally, and they can also provide the movement in a linear direction as well. So when uh, the omni wheels, when they are connected to a particular robot, they can actually transport the entire structure without having to resort to any other movement. So that's there. So yeah, we might have heard about this debate, SolidWorks versus Fusion 360. So there's a lot of debate going on with which software is better for beginners or what. So there are 5 points I'd like to discuss about these softwares. And for the untethered, I must tell you that SolidWorks and Fusion 360 are basically 3D designing softwares in which you can design any 3D model of a robot or a machine. So I'd like to discuss about five major differences between them. First is the OS compatibility, operating system. Fusion 360 works on both Mac and Windows, whereas SolidWorks works only on Windows. So that's a slight disadvantage that SolidWorks holds. Working. So Fusion 360 is like cloud based, in the sense you can get to save whatever work you have done till now on a cloud instead of saving it locally on your desktop. So this works well when you are in team collaboration and you need to inform each other of what specific part you have done in a particular work job. So that's there. SolidWorks doesn't hold that advantage. It's locally stored, all the files are locally stored, and all the work is locally saved. The third point I'd like to discuss is about modeling and simulation. So fine, we can work in team and we can work on Windows itself. But what is the advantage that SolidWorks holds over Fusion 360? So there are a lot of options to simulate a particular robot under any constraint or environment rather than Fusion 360. Though Fusion 360 has come up with simulation softwares in the recent years, but still it's nowhere as functional or as better as SolidWorks. So that's the advantage SolidWorks holds. Part assembly. So a robot might have many parts which require individual design. If we want to assemble them in a specific single file, then Fusion 360 is your go, because in that particular file you get to save all your work under sub files in that same file. So all the final assembly will take place under a single file, whereas in SolidWorks it does not happen like that. You need to save individual files for individual parts and then combine together to get a final model. So this might not work that well when you lose access to a particular file and then you would have to redesign the model or the component, and then it will take a lot of time. So that's a minor disadvantage of Fusion SolidWorks. The last is a user interface. uh, Here I might be biased, but Fusion 360 has the hands-on best user interface for a beginner. So there are many functions, modularities, etc., which will help a beginner to get started with any kind of design. SolidWorks is mainly meant for advanced mechanical engineers whose main goal is to get the job done with more functionality rather than to start from there. So that's there. But Fusion 360 is really great for anyone who's just starting to begin modeling in CAD. So that's there. Okay, so this is a hot topic, artificial intelligence. So artificial intelligence, you might think of it as a computer science subject, but it really has application in almost all aspects of engineering. electrical, mechanical, civil, chemical, etc. So, but we are concerned with mechanical design in in this session. So let's look at that. You might see these two images over here. These are completely AI design. Let me tell you. So this is how artificial intelligence has gone so far in advancing in mechanical engineering. So the advantage or the role of artificial intelligence is that once you give a model, nowadays you can build several networks in um, artificial intelligence, and we not go into the technicalities, but yeah, so you can train a few networks and try to optimize the design of the robot to provide more functions. So that's there. And then for manufacturing, for quality control, etc., to control the design, how much of force or load should be added. That was in the first part I discussed in the session. So yeah, artificial intelligence takes into account all these parameters and tries to incorporate and give us the best possible solution. So this is the role of artificial intelligence in machine design. So yeah, I'd like to conclude my session with that, and I'm open for any questions that you have. Okay, so a question has cropped up: in which scenarios do we use which motor? An example would be appreciated. Okay, so you might remember the 3D sketcher which was introduced to you in the orientation session. So in that we used a different kind of motor called stepper motor, I guess, if I remember. So we needed to perform. We need to have greater accuracy in sketching while sketching the portrait. So we need to perform the phase. We need to perform the operation in steps to have a greater precision. Stepper motors allows us that, but the disadvantage, as far as I know, is that stepper motors are a bit bulkier when compared to servo. So that's there. There's a second question: are any robots with caster wheels made? So not that I know of, but yeah, I gave you a possible, very common example of this thing. Yeah, but if you might have observed, Thoughtbot, which is a research project done by ERC, it has used Omni wheels. So that's there. That's the project that we have used the wheels for. That's the only project, I guess, in which we have used wheels. Caster wheels move in basically any direction. You can have a linear movement, you can have angular movement, you can have any sort of movement. So that's the movement of caster wheels. Which software do you use in ERC? Well, the seniors we use is Solidworks, but for beginners, I would really suggest you guys to start with Fusion 360 because it has a better user interface. But once you're acquainted yourself with the 3D softwares, CAD softwares, then you can easily switch on to SolidWorks. There's no major difference between Fusion 360 and SolidWorks. How do we learn to use these softwares? Any course for absolute noobs? We should have begun. Okay, so there are few YouTube tutorials that were put up on Discord in the past 2 3 weeks. We'll be reposting those links by tonight, and then you can follow those tutorials. They are very basic, easy to understand, and then you'll be learning them within a month. Should not take you more than a month. Okay, what do you guys suggest? Starting with Fusion and later moving to SolidWorks, or straight away starting with SolidWorks? First, start with Fusion 360. That would give you a better knowledge of how to operate in these kind of softwares, and then you can move on to SolidWorks as and when you feel like you have mastered or at least come to a level where you can handle these drawings. In the roadmap, I'm expected to master all domains or just the one in accordance with the branch. It's not necessary. You can master anything you want. You can learn anything you feel like. But these there are some basic stuff that you need to know that I have tried to incorporate most of those stuff in today's session. These are the very basic stuff you need to know, but you can specialize in any one of them. It's not a big deal. How should I begin with designing? I'm absolute noob. Okay, fine. Um, how to begin with designing? I'd rather have you start with the YouTube tutorials. They start with very basic designings like just designing a cylinder or just a very basic gear or some arm. That's it, which has L shape and we can move like this. So that's there. You can start with those. They are very easy to begin with. It'd be okay if we start learning about Fusion 360 before the workshop. Yeah, you can learn as and when you find time. It's not necessary or not required to stop until the workshop starts. Does Fusion 360 give any option to save live files locally so that we can use it without the internet? Absolutely. Because we can download any. You can download the file whenever you want in a specific format. Then when you save it on your desktop, and again when you open Fusion 360, you can you open the same file. But yeah, for the designs to be updated regularly, you need to be connected to internet because if you can work offline as well, but your design won't get saved to cloud. That's it. Can I start making a robot without knowing anything in prior? Uh, yeah, this is a really good question. So yeah, you can start a robot, making a robot without knowing anything. But yeah, robotics consists of three main aspects of engineering: electrical, automation, and mechanical. Without any of these subparts, you cannot start with other two. So it's really important that you need to have some basic knowledge in all these three fields before starting with anything. And once you are fairly acquainted with the basic knowledge, I'd rather suggest you to go through a few basic projects that ERC will be putting up or has put up in a short while, and then you can get started. Yeah, so there is a workshop being conducted. A few people have asked whether we'll be conducting a workshop. Yes, there will be a workshop conducted for Fusion 360 for beginners and for others who have some kind of experience but know absolutely how to make designs. Yeah, so that's there. There will be a workshop conducted. ERC will be notifying you in a few days. Um, yeah. So yeah, I guess we'll wrap up this session. Thank you guys, and we'll be meeting up real soon in the campus. Have a good day.